Alright, so the last session did not actually record for some reason, so I'm going to try again. So this is going to be a lot shorter than last time, and it is a recap. The topic of this session is how to deploy to production rapidly. So the idea is, if you look at I'm going to try again. So this is going to be a lot shorter than last time, and it is a... Alright, so if you take a look here, the total time from dev to production through automated is less than 10 minutes. So the idea here is to be able to push code within days as opposed to months or years to production through the entire process. Because when something goes wrong, if you have a very fast deployment process, then you don't have to worry about fixing it. Conversely, if you spend a month or 6 months or a year to create code before it reaches the general public, then you're going to have issues when things don't work as you'd expect them to, even from not just a code perspective, but from a business perspective. Because you want to get that feedback from the users rapidly. I mean, you have Lean Startup, Agile, Scrum, whatever you want to call it. And the way that our process works, we use a tool called Jenkins. And what happens is, first we have a user working on Visual Studio or whatever, and they use a tool called GitHub to sync up all their code, basically, so you have a central repository where all the code is and all the history exists. Once they hit sync, it goes to the central GitHub servers, and the servers then store the code. Now we have everything in a central repository. The repository can actually tell our build machines that something new happened. Our build machines can automatically build the code, do unit tests, and push to our development environment. And that happens generally within 3 minutes of somebody hitting sync. Once something's in the dev environment, they can make sure that the developer can make sure things are working in the normal code or the server code the same way it works on their local machine. And once they believe things are stable enough, they can click one button to copy from the development environment to the QA environment. Then QA can basically say, hey, this is great, I'm pushing to production. Click one button and 1 minute and 18 seconds later, things are live and everybody's happy. Or they can say, hey, you know what, this isn't good enough. And they tell the developer would do their thing. They click the deploy button to QA again, and this will repeat until the code is stable. This is important too because you want to make sure that if something goes wrong, or rather you want to make sure a developer does not have the ability to make a catastrophic problem with production. Because if they do, it's not really the developer's fault, it's their manager's fault for putting them in a position where they can do something without appropriate fail-safes. So part of this process is actually making sure there are fail-safes and making sure they happen very quickly. Unit tests and things like Jenkins or Cucumber are very big parts of that as well, but that's outside of the scope of Jenkins talk, which is what's going on right now. So the first thing is you have you're starting off with syncing to GitHub, and I'm assuming you know how source control works up to this point. GitHub is a Git tool that's widely used that has third-party plugins. One of those, if you go to Settings, and then I go Webhooks and Services, is a Jenkins plugin which can talk to build machines. So now we have our Jenkins, which is listening to the webhooks and services that GitHub sent down, and we've configured our permissions correctly so that now they can communicate. And once I do that, I can automatically spin up one of these automated processes without human intervention as soon as somebody pushes to dev. And there'll be a little red thing over here, and it's red and blue as opposed to green and blue for colorblind people. And the sun will be very unhappy. It'll show rain clouds or thunder clouds if things are really bad. And you can have plugins to send Skype messages or instant messages or emails, or even have Chuck Norris yell at the developer, or at least a virtual Chuck Norris, if something goes wrong. And yeah, so if we want to look at the steps of what's going on, let's take a look at shop, which is what I was working on originally. And I go to configure, and what I'm doing right now is configuring what we call a job. meaning one set of things to do. This job builds archives, and deploys to development. Build is what it sounds like. It actually runs a build, so that downloads the code, compiles it. Archive means take a snapshot of what was just compiled, so we have the QA version, the dev version, and the release version all archived as snapshots with different connection strings to different databases and different logging. And deploy obviously deploys it directly to development. And this job does all that. Now, before the job runs, it needs to know where it's running, because you have what we call a master-slave relationship, meaning that you have one master, which is in our case a very small CentOS machine that does nothing but host the web page of the tool that we're looking at, and talk to a lot more beefier machines that are called slaves that run all the heavy lifting. And it's really easy to install a slave on another Linux machine, on a Windows machine. It's a very old tool that's been around for a long time, and it's open source. In our case, we're running .NET code, and we want to compile it using MS-Build. So each one of our machines, there are 5 of them, that are build machines that are capable of compiling .NET code, are labeled as MS-Build. Then the next thing we need to do, and this is going to be a little out of order of Jenkins, but I'm going to go in order of actually what happens. So the next thing we need to do is going to do a build trigger, which is for some reason in the middle. What a build trigger is basically the instructions say this is what actually causes the build to happen. Now, obviously you can do this manually if you have permissions, but where it says build triggers when other projects are built, this happens when something that shop relies upon is modified. It automatically builds as well to make sure there's no domino effect of a cascading failure, and if there is, it will immediately build and fail and notify people, so you don't have to worry about one core piece of code breaking everything and not being able to figure out what's going on. The other bit that's really important for us is when a developer checks in their code, it will automatically build instantly. So because of what I just showed you with the GitHub, the GitHub webhook, it's smart enough to know, alright, I identify which GitHub project we're talking to and will automatically build. Make sure I'm still recording. I am? Great. Alright, then the next thing is telling the Jenkins how to actually connect to GitHub. We're using keys for credentials because passwords are, anybody looking at the stream can see a password that's bad, and I can't exactly easily change a password and tell everybody where I can revoke one key if something goes wrong. If you're wondering what submodules are, remember I was talking about dependencies earlier. So in this case, if I open up, well, let's take a look at the shop. The shop will see a reference to third party, which are basically the compiled DLLs from everything this depends upon, which think of it as a link in Linux, or a shortcut in Windows, or a pointer in C++, or something like that. It's a reference to another GitHub project, so I have one central thing, one authoritative source, as opposed to having to worry about copying and pasting everywhere, which has tons of possibilities of problems. So that's why we're using something called submodules. You don't have to do this. Sometimes it's a bad thing to do. For us, it never caused us any issues and actually the right thing to do, but this is situational. We're always grabbing the latest version of the dependency project, or in our case, all the dependency projects because we have multiple ones. But you don't have to do that, and you can actually say I want the older version of the dependency because I don't want to have to worry about, version 10 or whatever the latest version is, doing a cascade delete until something is proven stable. It's not a problem in our current situation, but you can check or uncheck that or add additional behavior as needed. I already talked about build triggers. The only reason you're seeing that again is because these are kind of out of order in the list. So now we're looking at build, which is basically the meat, meaning things that actually happen. Like this is what the job actually does after it has a source control. The first thing we're doing is running MS-Build. The build version is basically a bunch of environmental variables, like in our case, where the actual path is for MS-Build to run. Now, on a slight side note, for a long time you had, hard-coded paths where MS-Build was, but after the latest version of Visual Studio, some of the MS-Builds actually have different paths. Alright. And MS-Build itself is a little more in-depth than a simple SLN file. Basically, it's a set of commands to do a lot of things, even deploy, which is what we're doing now. And what it does is basically you have dependencies. In our case, we're saying our target is deploy, which means we want to push it to another server. And MS-Build is smart enough to basically be able to say, alright, deploy depends upon archiving, which depends upon unit testing, which depends upon builds, and that's all automated, so we just have to say this is the end goal we want. It'll go up the dependency train and automatically reach a point where we want to go. We're using something called web transforms, which web config transforms, which I will talk about later if I have any questions about it. But essentially what this does is say, I want to generate a snapshot, or I want to generate something using the debug connection strings. Because we don't obviously want to connect to the same database in QA and release and dev. The next thing we do is create an archive, which is basically a snapshot. That all these snapshots are going back to what I talked about earlier of copying it from dev to QA, from QA to release, and we want to make sure we have exactly the same version of the zip file with nothing different but logging and the configuration such as connection strings. So those are all copied to a place where we can grab them later for an archive step. We build again with the QA configuration, which should do exactly the same output, with just as a web transform to make things connect to the QA server and possibly do things with logging, and again with release. Once that's done, we archive our files, and which means that we have the snapshots, and now other Jenkins jobs can grab those and work with them in the future.